We now introduce the concept of permutation by considering an example. Consider three books with three different colors, red, blue and green. Suppose a bookshelf has space for only two books. In how many ways can we arrange the books in the bookshelf? Well, the bookshelf has space for only two books. So with the given three books, we could perhaps choose the red book first, followed by the blue book to give us a red-blue arrangement in the bookshelf. Or we could reverse the order of picking, pick the blue book first, followed by the red book to give us a blue-red arrangement in the bookshelf. Likewise, we can have the red-green arrangement or green-red arrangement in the bookshelf, or the blue-green arrangement or the green-blue arrangement in the bookshelf. In total, we can have 6 possible ways of organizing the books in the bookshelf. Now, how can we compute the number of possible ways of organizing the bookshelf? We could easily do that by considering the spaces in the bookshelf. There are 2 spaces in the bookshelf, and for the first space we have a choice of 3 books, and once we've selected a book to go into the first space in the bookshelf, we have 2 choices for the second space in the bookshelf, and 3 times 2 gives us the total number of possible ways of organizing the bookshelf, which is 6. And this is an example of a permutation because the order in which we pick the books influences the number of possible ways of organizing the bookshelf. Now let us introduce the concept of combination by considering an example again. Let's consider a different example. Consider 3 students, John, Jack and Jill. Suppose we want to form a team of 2. In how many ways can we form a team of 2 with the given 3 students? Well, we could pick John and Jack to be in one team. So that is one possible team that we can have. And also notice that if we reverse the order of picking these students, if we pick Jack first followed by John, it does not give rise to a different team. A team that consists John and Jack is the same as a team that consists Jack and John. Likewise, we could pick John and Jill to be in a team. Even if we reverse the order of picking these students, if we pick Jill first followed by John, it doesn't give rise to a different team. It is still the same team. A team that consists John and Jill is the same team that consists Jill and John. We could also pick Jack and Jill to be in one team. Picking Jill first followed by Jack does not give rise to a different team. So the order in which we pick the students in a team does not alter the total number of possible teams that can be formed. In this example, the total number of teams that can be formed is 3. This is an example of a combination because the order in which we pick the students does not determine the number of teams that we could form. Let's now define permutations and combinations in more general terms. Consider n different objects and selecting r objects from a pool of n objects. So in a pool, we have n objects in a pool. and we are picking R objects out of a pool of n. Now, in forming this smaller group of R members, if the order in which we pick these R objects out of a pool of n gives rise to a different group, then it is called a permutation. If the order in which we pick the R members into the smaller group, if the order in which we pick the members does not give rise to a different group, then it is called a combination. So how do we compute the number of permutations? Well, if we are picking R objects out of a pool of n, we would draw R boxes. So we would draw R many boxes, and in the first box we would write down the number of choices for this box. We would also write down how many choices are there for the second box, and we'll continue this process until the last box, and we would write the number of choices for that box. So in total there are R boxes, and the number of permutations is just the product of all these numbers in these boxes. Well, how do we determine the number of combinations? When we have a pool of n and we select R objects out of that, the number of possible combinations are written as NCR, and it takes the value of n factorial over n minus R factorial times R factorial.